I want to do a couple more problems involving piecewise functions. Let's start with this one. Suppose f of x is equal to negative 2x plus 1 when x is between negative 3 and 1, and it can equal negative 3 but not 1. Let f of x be equal to 5 when x is between 1 and 2, and we can equal 1 and 2. And let f of x be the square root of x when x is greater than or equal to 4. Let's find the following. Let's evaluate the function at negative 1, 0, 1.5, 2, and 16. So maybe take a minute and copy this function down, and then write out, just like I've done here, f of negative 1, 0, 1.5, 2, and 16. If you can, go ahead and try to solve these. If you can't, watch me do the first one and then pause the video and do the rest of them. Okay, f of negative 1, well, remember that this value, negative 1, is your x. So you're going to look over here and figure out where x is able to be negative 1, which happens to be this first interval when we're between negative 3 and 1, because negative 1 is in between negative 3 and 1. So what we're going to do is we're going to plug negative 1 into this equation here. So negative 2 times negative 1 plus 1 is 2 plus 1, which is 3. Now let's try f of 0. Again, we look on this side and see where we can be 0. Well, 0 is between negative 3 and 1, so we're going to plug it into this one as well. So negative 2 times 0 plus 1 is 0 plus 1, which is 1. How about 1.5? Well, 1.5 is between 1 and 2, so we're going to go with this equation. Notice there's no x's here, we just have a 5. So that means that this function is going to be equal to 5 for anything between 1 and 2. So when we plug in 1.5, we're going to get 5. That's true for this one as well, because 2 is between 1 and 2, and we're going to plug in x is equal to 2, but there's no x, so we just get 5. How about 16? Well, 16, that's greater than or equal to 4, so we're going to go with the square root, and if we take the square root of 16, we get 4. So these are the values of the function at these particular x values. Remember, if we try to graph this function, we're going to have the following points on the function: negative 1, 3, 0, 1, 1.5, 5, 2, 5, and 16, 4. And that's because these are our x values and these are our y values. So that's the next step. Let's try to graph this function. So I have f of x is equal to these three pieces. And what we're going to do is we're going to graph each one of these functions, and then we're going to erase the pieces that we don't need, so where x is not defined. I'm going to zoom in a little bit. Okay, so let's start with this function here. Let's say y is equal to negative 2x plus 1. So this is a line. The slope is negative 2, so we go down 2 and to the right 1, or we can go up 2 and to the left 1, and the y-intercept is 1. So let's try to draw this. So we're going to go through 1, go up. Now remember, each one of these tick marks you can see is a unit of 1/2. So to go up 2 would be going up 1 unit. So 1, 2 over 1, up 2 over 1, up 2 over 1, and also down 2 over 1, down 2 over 1, and you can continue. Now I'm going to try my best to draw a straight line. It's hard for me to draw straight lines on this software, but I'm going to do my best. So we're going to go through here, 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 and this is going to continue upward. Then go Okay, so the straight line looks something like that. Now what I'm going to do, now make sure you've drawn this as well, and draw in pencil. What we're going to do is we're going to erase when we're not between -3 and 1. Okay, so let's find -3 on the x-axis. Here's -3, and here is 1. So when you're not in this area here, so if we could draw a straight line all the way down here and here and up as well. When you're not between these two lines here, you're going to erase the graph. So we're going to erase this piece here, and we're going to erase this piece here. I'm also going to erase all this green. So we erased the part that was bigger than 1, and notice that there's no equal sign there. So we also need to put right here where this dot is, let's make that an open circle, because we're not defined on this line when x is 1. And then when x is -3, we are defined, so we have a closed circle here. So we just have this line segment. So that takes care of this first piece. The second piece says that we're equal to the horizontal line 5, because this is y is equal to 5, which is, I'm going to do this part in green right here. So let's just draw I'm putting dots here for a reason. You can just draw a straight line like this because you can erase. I guess I can erase too. It's just that I have a, you'll see what I mean in just a second. So, okay, I'm going to draw this piece here, and now I'm going to draw this. So just draw a straight line that goes through y is equal to 5. Okay? Now what I'm going to do is I'm going to erase anything that's not between 1 and 2. Now let's find 1 and 2. X's 1 is right here, and X's 2 is right here. And you're going to see why I broke this line into pieces, because I have this stroke eraser, which gets rid of like a big portion of the line. So I'm going to erase this piece, and I'm going to erase this piece, and I only care about this piece, because that's when X is between 1 and 2. So I'm going to make this piece black like the rest of the line here. And notice that we can put solid colored dots right here and here, because X can be 1 and 2. Okay? Now we have one more piece of this graph. We need to take care of the square root function. So this is one of those functions you need to memorize. I'm going to do a few points to help you remember what it looks like. So we take the square root of 0, we go through 0, square root of 1 is 1, square root of 4 is 2. So the graph looks something like this, right? And it stops right here. Now, we're going to erase the portion of the graph that's not bigger than or equal to 4. And that happens to be, so here's 4. Anything above here is okay, but this piece is not okay. So now let's make this one black. All right, and we've graphed this function. So the function was these 3 pieces, these 3 lines, for these particular intervals for x. And that's what we have here. Make this a bigger dot. We can equal 4, so we can put a solid dot here. We're solid on these 2, so we have a straight line here corresponding to y is 5. This is this line here, and then the square root of x is like this, but we erased this piece. So this is our function. Let's double check these points that we wrote out. We said that -1, 3 is going to be on the graph. I'm going to copy these so we can, or actually let's just move them down and see if we can find them on the graph. We said that -1, 3 is on the graph. Well, let's see, -1, 3, that's correct. The point 0, 1 should be on the graph, so 0, 1, that's on the graph. 1.5, well here's 1, Let me zoom in a little bit. Here's 1, here's 1.5. If we go up, we'll see that y is equal to 5 there, so that's true. Also 2, 5 is there. And then 16.4, that's a little bit further out on my graph. I don't have it, but if I put more tick marks and I made this bigger, I could see it. And in fact, it does correspond to this piece. This piece right here is the square root of x, so if we did put 16 in here, we'd get 4. So this would go through 4. Okay, so we've graphed that piecewise function. Let's find the domain and range of this function. So let me move this up a little bit so we can see the function. I'm going to get rid of this stuff so we don't have too much going on. It's not so busy. Okay, so I did mention in my last video that we can tell the domain just by looking at this, and that's true for this case as well. And you can also tell the domain by looking at this. But you see that the smallest number you're allowed to be is -3, because we stop here. Then we go up to 1, but we can equal 1 in this interval. We go to 2. We can equal 2, but then we jump to 4. So we're actually taking out anything that's less than -3 and anything between 2 and 4. So the domain here, let me write it like this. The domain, I'm just going to use D, is equal to -3. We're covering all of these numbers. We go up to 2, union, and then we can go from 4 to infinity. Let's see if that's shown in the graph. So looking at the graph, you can see the farthest to the left we go is -3, which is true. Then we go this way. We've got points on this line for everything. When we get to 1, we don't have a point here, but we have it here. And as long as we have a point, we're good. Then we have a point at 2, that's correct, just like we thought. But then we have a jump. We don't have anything between 2 and 4, and then 4 to infinity, we have points. Now let's go with the range. So for the range, we're going to look at the graph. We're not going to look at the equation. Remember, the range is how far up and down we go. So looking at this, it looks like the furthest down we go is 1, -1, but we're an open circle there, so we don't include it. And then as we go up, you can see we have points everywhere. We keep going up. We got some on this side as well. But we stop at this point right here, which looks like a 7. And that corresponded to this when we plugged in -3. So if we plug in -3, we do get 7. So that's true. So it's going to be from -1 to 7, but we don't include -1, and we include 7 because we have a colored in dot right here. Okay, let's list any intercepts. So remember, we're going to have 2 types of intercepts. We're going to have x-intercepts and y-intercepts. X-intercepts correspond to when we plug in y is equal to 0. Y-intercepts correspond to when we plug in x is equal to 0. I always think x is equal to 0 is the easiest, so let's just look at our equation. Where do we have 0? Well, 0 is between -3 and 1, so all we have to do is plug in 0 into this piece. We don't plug it into any of these pieces, just this one, because that's where it's defined for x is 0. So if you plug in 0, you get 1. So the y-intercept is 0, 1. Okay? And we can also look at the graph, and you can see at 0, 1, we do have a point. Let's find the x-intercepts. So we're going to plug in 0 for y. Now we have 3 pieces. We can set each one equal to 0. So let's do that. So -2x plus 1. I'm going to do this in a different color. -2x plus 1 is equal to 0. We had 5 is equal to 0, and the square root of x is equal to 0. Remember, we plug in y is 0, which means f of x is 0, and we had 3 equations. Now let's solve each one for x. So this will be x is equal to 1/2. Subtract 1 and then divide by 2. Here, there's no x. 5 is never equal to 0, so it would never go through the x-axis, and this one says x is equal to 0. Now, we have two possibilities, 1/2 and 0. But we need to make sure that these values are inside our domain. So is 1/2, so since we use this piece to get that 1/2, is 1/2 in this domain? The answer is yes, right? Because 1/2 is less than 1, but it's definitely bigger than -3. So 1/2 works. The other one that we found, x is equal to 0, well, we looked at setting square root of x equal to 0. But square root of x, when we set it equal, like we can't set it, we can't get x is equal to 0 because 0 is not greater than or equal to 4. You can see, like if this piece continued and we had a full circle here, then definitely we would go through that, but we erased that piece. So we only have one, as you can see, x-intercept, which is right here, and we said it was 1/2. So the x-intercept is 1/2 comma 0, because we're setting y equal to 0. Here's the last problem. I just want to see if we can find an equation for this function. So find an equation for the function f with the following graph. So I've been giving you the equations and we've been drawing the graph. Now we're doing this backwards. I'm giving you the graph and I want to find the function. Notice that there are 3 pieces. I have 1, 2, and 3. So what I expect is to have 1, 2, 3 pieces for this function. And then I'm going to put ifs here, if, and I need to define a domain for it. So let me erase these little blue circles. Now let's continue this graph. So this looks like a straight line, right? So if I wanted to continue the straight line, it would go, it looks like it would go through here. It looks like, I'm just going to draw an idea of what this is. This looks like a piece of a straight line, and it is. This one is also a piece of a straight line. Like that. In fact, these look like parallel lines. So if you have a straight line, just imagine like a portion of a straight line extending this. You can extend this here. And this one, if we just have a point, we're going to make it a horizontal line, okay? So what is the equation of this particular line? Well, notice that we're going through 4. So I'm going to put a 4 here. That's my y-intercept. Remember that the slope-intercept form is mx plus b. What is my slope here? We're going up 1 over 1, up 1 over 1, up 1 over 1. So the slope is 1. So this is 1x plus 4. That's the equation of this line right here, x plus 4. But we erased this portion of that graph, which tells me my domain, right? X is between -4 and 0. Let me zoom in some so you can see it a little bit better. You can see that when x is -4, we have a point here all the way here to 0, which we have a point there. So if x is between -4 and 0, and we can equal these two because we have colored in dots. Now let's give an equation of this line here. Okay, this line is going through the origin, and its slope is up 1 over 1, up 1 over 1. You could say up 2 over 2, but 2 over 2 is 1. So the equation of this one is 1x plus 0, because that's the y-intercept, or just x. And notice that the domain here, well, we're getting rid of this portion of the graph. Sorry, that was a full circle right there. And then we're getting rid of this portion of the graph, which tells me that x is going to be between 0 and 2. Now we have to ask ourselves, can we put equal signs here? And the answer is no, because these circles are not filled in. Let's talk about the last one. Now, if you just see a dot, what you're going to do is use a horizontal line. And notice that the equation of this horizontal line, well, this is going through -4. And we remember the parent function of a constant like horizontal line was y is equal to b. And here b is equal to -4. So this is just going to be -4. And this is true when x is only equal to the number 2. Because this is the only value we get. So we get that 1 point there. We don't get a bunch of points. So this is the equation for this function. Let me put it all in black here. There we go. Looks a little bit nicer. Yeah, so this is the equation for the function. And you can double check by trying to graph it and make sure it's correct. Let's look at the domain and range just as an extra exercise. What is the domain? Well, you can see that the domain is -4. We have something at 0 all the way to 2. And at 2, we have an open circle here, but it's colored in there. So we stop at 2. The range is how far up and down we go. Notice that we have a point when we're at -4, and we don't have anything between -4 until we get to 0. I have an open circle here, but it's filled in there. So union 0, and then we have points all the way to +4, and that one is filled in. So that is the range.